Well, how do we determine empirical formulas? Empirical means from experiment. We can determine an empirical formula from an elemental analysis. So we'll take a compound, break it down or decompose it, and find out how many grams of each element there are. Alternatively, we can look at the masses of elements that we start with and how those combine. We can fix it so that one gets completely used up, and then we separate off the one that was not used up, and we've got the mass of our final compound. We can also find an empirical formula if we're given a percent composition. Maybe somebody else did the problem and found the percent composition. It's important to remember that the empirical formula is a ratio of atoms or of moles of atoms. It's not the ratio of masses. So the steps in finding an empirical formula. First, we need to write down the masses of each element. So sometimes you just have that. It says, well, this many grams of oxygen, etc. You just write them down. Sometimes you're given, though, a percent composition. And then we can change that percentage into a gram, a mass, by saying, well, let's just say we have 100 grams. If I had 100 grams of that compound, then I would have a mass equal to the percent composition. And so you can just take the percent off and write gram. The next step is to take those masses and convert them into molar masses so you get moles of each element. Then your book says write a pseudo formula using the number of moles as subscripts. Personally, I think that's dumb. Take all the subscripts, I would say all the moles, by the smallest number of moles, because we're trying to get ratios of moles. A lot of times you get a nice whole number or really close to a whole number. Sometimes it comes out a little funky. So this is my guideline. If the result is within 0.2 of a whole number, you have my permission to round it to the nearest whole number. If it's not within 0.2, if it is 0.20 different or higher, then you're going to have to multiply to get a whole number. So if you multiply 0.2 by 5, you're going to get a whole number. If you multiply 0.75 by 4, you're going to get a whole number. So some of you may recognize that these are decimal equivalents of fractions, right? 1/2 is the same as 0.5. So if you have 0.5 and you multiply by 2, you're going to get a whole number. Important thing is, if you're going to multiply one of these by a number, you have to multiply all of them because we need to keep the ratios the same. So those are the instructions. Let's do an example. Sample of a compound is decomposed in the lab, produces 165 grams of carbon, 27.8 grams of hydrogen, 220.2 grams of oxygen. Calculate the empirical formula. So the first thing is write down the masses of each element. So 165 grams of carbon, 27.8 grams of hydrogen, and 220.2 grams of oxygen. The formula has ratios of moles or of atoms, and so we need to convert these from masses into moles. And we do that using the molar mass of the element. So we want grams on the bottom and moles on top. So carbon would be 1 mole per 12.01 grams. Hydrogen, 1 mole per 1.008 grams. And oxygen, 1 mole per 16 grams. So then we got a little math to do. 165 divided by 12.01.
Do you care if we use 15.999?
You can use 15.9994 if you want. That's fine. So here I've got 165 divided by 12.01. I'm getting 13.7. My starting number had 3 sig figs. What's important in these calculations is not that you keep track of the significant figures. They're going to end up taking care of themselves in the end. What is important is that you not over round. So use too many digits. Use at very least, the number of significant figures, but it would be better if you use 2 extras. And if you want to use all of them, that's fine too. So this would be moles of carbon. 27.8 divided by 1.008. So this is going to be 27.5, just writing down 2 extras, moles of hydrogen. And then we've got 20.2 divided by 16. 13.7625 moles of oxygen. So those are the moles in this particular sample. So I could write, C 13.738, H 27.579, O 13.7625. But we need to find what the lowest whole number ratio is. So I'm going to look at my numbers of moles, and I'm going to pick the smallest one, because my numbers need to be integers, 1 or larger. So I'm going to pick the smallest one, which is this one. I'm going to divide everything by the smallest one. So when I divide this by itself, of course, I get 1. Yeah. Of course it is. It can make a difference. Yeah. So I'd like to pretend I was trying to trick you, but alas, it's Tuesday, but my brain thinks it's Monday. This one's smaller. We have to divide by the smallest one. 17.38, and up here, this one is 13.738. So that one ends up being exactly 1. 13.738. Okay, so I've got 27.579 divided by 13.738 equals. And so this is 2.0074. And the one on the bottom is going to come out really close to 1. But we should really do the math just to be sure. Yeah.
I was taught to do this with subscripts. So what are you canceling out by not doing it with subscripts?
Okay, so the subscript method, which is what the book shows, the subscripts say you should do this. And then what are you supposed to do? Do the same thing? Yeah, you're supposed to divide these. That's supposed to be a 3. Right? You take them and divide it by the smallest one.
It's just an extra step.
I think it's just an extra step to write this over here.
Yeah.
And every time you have an extra step and write stuff down, you've got an opportunity to make a mistake. Like I did right there, I wrote an 8 instead of a 3. So it's the same thing. So I get my moles and I find the smallest. I divide them all by the smallest. This time they all came out to whole numbers. This one is 0.007 away from the whole number. This one is 0.001 away. And my guideline, my personal guideline, is 0.2. So if it's within 0.2, you can round it. So we can round these. So we'll call that 2, and we'll call that 1. Now those are my subscripts in my formula. So the carbon has a subscript of 1, which I don't write. The H has a subscript of 2, the O has a subscript of 1, and there is my empirical formula. Any questions? Here's a percent composition problem. Ibuprofen has the following mass percent composition. What's the empirical formula? Well, we could look on a previous slide and see the formula, but the point here is to learn how to do the problem. So the percentages, I'm going to take the percentage and say, well, if I had 100 grams of this, I'd have 75.69 grams of carbon. So I don't have to do anything except change percent to gram. So for the carbon, I've got 75.69 grams of carbon. I'm going to convert that to moles of carbon by dividing by the molar mass of carbon. For the hydrogen, I just drop the percent and write gram, 8.80 grams of hydrogen. Converting to moles, 1 mole of hydrogen is 1.008 grams of hydrogen. And then oxygen, 15.51 grams of oxygen, convert to moles.
Well, we didn't need to convert from empirical to molecular.
We'll learn how to do that, yep.
Oh,
It's not yet. So here, my starting masses had 3 or 4 sig figs, and so I want to keep, several here. 8.8 divided by 1.8. 8.7301. 15.51 divided by 16. 0.96. 93, and what the heck, 75. Keep at least as many sig figs as the percent or mass you started with. Identify the smallest one, divide them all by the smallest. So that one's just going to be 1.
Problems where there's no clear relationship, or for the most part they should line up?
Well, I think this one is going to end up with not a nice whole number.
So I remember in 3A, wasn't there something where you could double it?
Yeah. Yeah, we will need to do that sometimes. 6.3022 divided by 0.969. So can I round all of those to whole numbers? I can't do this one. This is 0.5 away from the whole number. That's too far to round. This is in the middle between 6 and 7. So you can look at the table. It tells you if this is your decimal that you have, this is what you multiply by. You can recognize decimal equivalents of fractions. Or the trial and error method works really well here. If all of that's like, wow, try 2, multiply by 2. If that doesn't work, try 3, then try 4, then try 5. You usually don't have to get that far. I have this number in my calculator. I'm going to try multiplying by 2. Oh, there we go. Whoops. I have to say what I'm doing. Times 2. So this is 13.0029. Can I round that to a whole number? Yeah. So that I can call 13. I had a ratio going here of 6.5 to 9 to 1. That's not the same as 13 to 9 to 1. If I multiply this one by 2, I have to multiply all of them by 2. So this one times 2 is going to give me 18. And this one times 2 is going to give me 2. This is the lowest whole number ratio. 13 to 18 to 2 cannot be simplified in whole numbers. So 13 is the subscript for carbon, 18 is the subscript for hydrogen, and 2 is the subscript for oxygen. And that's the empirical formula. Any questions?